workshop on biostatistics, and we have our esteemed resource person for today's session. So, sir will take session on sampling techniques and sample size calculation. So, Professor Rajiv Kumar Malhotra sir is with us. So, sir has been the faculty and biostatistician in the AIMS New Delhi, and he has been associated with various projects of ICMR, and he is the core committee member of Biostatistics Consortium, and he is known for his sample size calculation specialization. So thank you so much, sir, for being with us, and thanks for giving your valuable time. Over to you, sir.
Thank you, Dr. Dharmender. Good evening to all the participants, and thank you to Dr. Dharmender and Resilient for inviting me for this session. Today we will learn about some brief of the sampling method and sample size calculation. And both of these are very important in the designing phase of the study. And once you calculate the sample size and did the sampling method, you cannot
recording in progress.
You cannot redo that. So you have to take care about while doing this one. So this is our topic of the today session, sampling methods and sample size determination with examples. Myself is Dr. Rajiv Kumar, and then I will suggest you to first you download this calculator of sample size that is called Statulator, and you can download from the statulator.com. So we will do hands-on on this calculator, and also you can open the sealed envelope website for this one for randomization. So both of things you can open simultaneously. Both of things you can open, and we can do the hands-on on these for randomization and sample size determination. So this is the outline of this session, sampling method and randomization in experimental study, understanding of statistical inference and importance of the sample size in medical studies, and sample size for the descriptive studies for determining, estimating the mean, estimating of prevalence. And then we know about some various adjustments that need to the sample size for descriptive studies. And after that, we will go for some comparative study example, 2 independent sample mean comparison and 2 independent sample proportion comparison, and then we can have one example for the odd ratio and relative risks, how to do calculation for if we have a odd ratio and relative risks. Then we go for the introduction to the online calculator for this. That is a statulator. I will explain how to do the calculation on the statulator. So this is the outline of our session. So first we will discuss about the sampling and randomization. So there is a difference between the sampling, random sampling and randomization. So first I will try to explain that. Sampling means you are drawing the sample from a population, and randomization is you have a number of subjects are there, and you are randomized into the 2 or more groups. So random sampling is generally we applied in the survey study, where the descriptive study, survey study, where we select the subject from the population and then do the estimation from the sample and then generalize to the population. So this is the sampling method. And randomization, as I already told you, that we do in experimental studies to balance the known or unknown confounding variables. So this is used in a clinical trial or some randomized trial, and random sampling is for the survey design. So you have to understand what is the meaning of this one first. There are various types of random sampling, and this is called a probability sampling. I am not discussing non-probability sampling. here, but I am only discussing the probability sampling. There are four type of probability sampling. First is the random sampling method. Second is the systematic random sampling. Third is the stratified random sampling, and fourth is a cluster random sampling. So I will take a visual example to explain all these four type of random sampling. So this is the example I have taken from the website. First is the first is here random sampling. So we have a number of population is this is our population, and we draw a random sample from this population. So this is the random first subject, second subject, third subject, fourth and fifth. So five subjects we are drawing from the this population. That is called a random sampling. So in that random sampling, what we know we should know about the all the list of the participant. So this is the difficulty task for this population to know about the all these things. In same way, in systematic sampling, we know about the list of the participant also. So in what we do in the systematic sampling, we apply a systematic method. For for example, I say ki, I will select every seventh subject in the population or every K subject in the population. So uh, every K we will select. So for this, we what we know, we should know about the whole list of the population. So generally, these type of list we don't know or we don't have about this if we are doing the big survey for this one. And sometime for some examples, if you have some finite populations are there, in that case you maybe have a list. I am taking the finite population example. After that, uh, third is a stratify sampling. Stratify sampling means we stratify the population into the two or more group. So in that case, what we do, suppose we stratify according to the gender for male and female. What is the use for this? To minimize the error. In that case, minimize our objective is for estimation is to minimize the error. If we minimize the error, we can precisely estimate our uh, target uh, object for mean or standard deviation. So stratify sampling is we stratify according to the some homogeneous group like in male or female, or we uh, age criteria less than 18 or 18 to 50 or greater than 50. So they are, this is called a stratify method, or we can stratify according to the some other according to the hospitals or some other method, whatever you want to for minimizing the stratify this one. Second, fourth is the cluster sampling. In the cluster sampling is what we divide the population into the number of clusters, and then we select randomly from the uh, clusters and take the all the subjects in the that cluster. So what is the difference between the stratify and cluster? The stratify we are divided into the homogeneous group, but in cluster sampling we are not dividing into the homogeneous group, we are divided into the clusters. And then we are randomly selecting the clusters, and after that in each cluster we are taking either random or we include the all the subjects in that. So then I will take a one practical example for all these things to explain further. For example, a researcher want to assess a proportion of bullying experienced by a student of 6 to 12th standard in a school of strength 2000. Now here we have a population is 2000. There is a finite population, so we can have a list for this one. He decided to take a sample of 200 subjects. So he decided to take sample 200 to find out the proportion of bully experience. So first is we go for the random sampling. Random sampling, he have a list of 2000 subjects, and he draw using the random computer generator random number for the 200 students, and can find out the proportion of the bully experience. What in a systematic random sampling, what we do in systematic random sampling, because he has to collect the 200 students. So what we do, we divide the population divided by the number of samples, so we get the k value for every 10th student will be selected, so that we can get a 200 sample. Now we come to the stratified sampling. In stratified, we all know that the bully is dominated in the male as compared to the female. So what we do, we stratify the our students into the male and female, and then uh, from the male and female we randomly select the boys and girls, and then we find out the what is the bully experience. So in this case, you find that there is a homogeneous group, boys and girls for this. Or we can also stratify according to the class also, 6 to 8, 8 to 10, or 11 to 12 for the stratified random sampling. So this is the way of doing the stratified sampling. Now the cluster sampling is that in cluster sampling, what we do, we select a section. If we have a each section have a 50 students, and for 6 to 12th we have a suppose each section has a six section. So in that case we have a 42 section. So in 42 section, we randomly select 4 section and include all the subjects that is available in the that class, that is on an average 50 basis. So it may be more, 200, or it may be 190, or maybe 210. That depend on the strength of the student in the that, because we are taking here the average value of this one. So maybe on an average 200, some have a 55, some have a 45, 48. So that means in that case we can do a cluster random sampling for this one for finding out. So these are the one example how to go for the random sampling, stratify random sampling, stratify random sampling, systematic random sampling, and the cluster random sampling. Now we come to the randomization. What is the meaning of the randomization? Randomization is applied in the experiment, as I earlier told you. We had do in randomization in the control trials to uh, eliminate the known and unknown confounder for this. So there are different method for randomization here. The first is a simple randomization. In simple randomization, what we do, we take a coin and toss, and then selected uh, or based on the die roll, or nowadays a computer generated random tables are available, so we can use that tables to find out the sequence of randomization. But if you do the coin and die roll, there is some problem of imbalancing in that case. So what the solution for balance is block randomization. Block randomization is balance. In that case, you can fix the block size of 2 or 4 or 6, or you have a variable block size. In that block size, we do the randomization. So I will take the one example for here. In this block size is a 4, size is 4, and we have to randomize treatment A and treatment B. The first patient goes to A treatment, second patient goes to A treatment, third is B, and fourth is B. So in that case, in each block, there is a two A treatment patient and two is B treatment patient. So that is called balancing for this one. Similarly, in the second block, you have a all this is a fourth size block. So same is first subject is a B, second subject A, third subject B, and fourth subject is A. In that case, we have a balance of 2A and 2B. So what is the main drawback of this if we are using the fixed block size is that if I know that first is A, then second is A, third is B, then fourth is automatically with B. So this is a non-randomization method. So in that case, here the problem is come because you can find out if the 3% are, you can know about that treatment group. So fourth one is the you can access for that one which group it will lie. To avoid this, we use a various block size method. So we can not fix block size. We can use the two size, four size, six size. If you are having a two group, then you use multiple of two. If you have a three groups, use multiple of three. Yani means 3, 6, 9. Or if you have a two group, then 2, 4, 6, 8. So you have to take care about what is the block size you are using. That is a multiple of your number of treatment. Now we come to the stratify randomization. Problem is come here. Problem is that in randomization, we can adjust the confounding factor that is known and unknown, but we cannot adjust the prognostic factor or covariant that affect the study outcome. Some are the in oncology we found that there are some are the prognostic factors. So in that case, we that cannot be adjusted by the baseline randomization. In that case, we do for the randomization method, or we can adjust these factors in during the statistical modeling. So I am explaining here the stratify randomization by this one. Dr. Dharmender, there are some persons are doing this one. Hello, Dr. Dharmender, can you hear me? Dr. Dharmender, so again, can you hear me, na? Dr. Dharmender, can anybody mute and tell me you are hearing me? Na? You can write on chat box also. Okay. Now I will explain the stratify randomization. Stratify randomization, as I told that there is to balance the prognostic factor or covariant. Baseline randomization balance the known and unknown covariants, but they are not balance the prognostic factor that those factors that influence the during the after randomization. So in that case, we can do the stratify random sampling to avoid this. So first is what that generally we use in a oncology. For example, we say that sex may be the affecting prognostic factor. So we divide into the two strata, male and female, and then we do the simple randomization or block randomization within the strata. I am giving this one example for this one. We have a three factors: site, sex, and age. There are two sites, then sex male and female, and then the age band. We have a three age band: less than 20, 20 to 64, and greater than 65. So in that case, we have a three factor prognostic factor to balance. So if there we have a three, so how much strata we required? That is depending on the number of categories. We have a two categories. Here the gender has a two categories, 2 multiplied by 2, 4, and then age has a three categories, that is 12. So we need a 12 strata here. And for each strata, we do the random sequence. The problem here is that as you number of prognostic factors are increasing, the number of strata are going to increase. So problem, we cannot get the adequate number in for the each strata. Uh, Recently, I do the stratify sampling in an office for a one project, and then later I found that there is a one or two strata we are not able to get. So these problem is appear in the stratify sampling. So you have to take care while you are taking this one randomization for the prognostic factor. Then you take minimum to minimum prognostic factor, either one or two. If you have a more than two or three, then their problem will appear. So this you have to take care about that for the randomization, certify randomization. Now, there is another method that is some complicated method uh, that is called minimization randomization. Minimize randomization is that is also known as a adaptive randomization. What we do a dynamic randomization here. In dynamic randomization, what is the meaning of the dynamic randomization here? We don't know about the randomization in starting. As the patient come, then we find out it will go in a treatment group or it may go in a control group. So I will this is generally done by the computer. So I will just explaining one uh, what is the brief criteria for, or what is the theory for this one minimization randomization. For example, uh, first we have a uh, first we select a patient randomly, and we found that the first patient is a male patient, 5 year, sites 2, and we assign this patient into the treatment group. So we make this table, that is a prognostic factor. Site is 1 and 2, sex is male and female, age band is less than 20 to 64, greater than. So we have a three progressive factor. We assign 0, 0, 0 to the first patient. If you assign, if it is assigned to the control group site 1, then we apply 1. Otherwise, we go for the right 0, 0. So first patient is a treatment group male. So we write 1 for the male, 25 year. This is the 25 year. 25 year age band we assign 1, and then side 2 we assign here as a 1. Now we first patient we already assigned, then we assign the second patient. If the second patient come to you as a side 2, from the side 2 female, and the age is 25-year-old, so in which group it will lie? We have to calculate the total number of imbalance in the control group, total number of imbalance in the treatment group. How you calculate this one? You calculate this one is first site. In that case, in site we have a 1 minus 1, that is in control group 1 minus 1, site is there already assigned is 1. 1 minus 0 for the female there is a no, then we assign 1 minus 0. And here the 25-year-old, that is already there, 1 minus 1, that is equal to 1. So total number of imbalance in control group is 1. Total number of imbalance in the treatment group. Treatment group, if you assign this patient into the treatment group, what will happen? It will become 2. Treatment group become 2. So 2 minus 0. Then female. If you assign the female 1 minus 0, because here 1 minus 0, and 25-year-old, it will become 2. Here, if you assign to the treatment 2 minus 0, so it will total number of imbalance is 5. So you can write here and then increase the score. Now the minimum is in the control group. So the next patient will assign to the control group. So I will take another example for this one. Now next patient come to the from the site 1, sex is male, and then 15-year-old. Now, what is then a total number of imbalance in control group? Site is 1. If you assign to the control group, it will 1 minus 0. Yeah, here is 1. This is minus 0. Then male. Already male. There is no male. 1 minus 0. So the imbalance is here. 1 minus 0. There is a balance is there. Now, for the age, we go for the age, that is 1. If you assign to 1 minus 0. So this is number is 2. Now we come to the treatment group. In treatment group, the site is what here. If you assign treatment group 1, so that is minus 0. 1 minus 0. Okay. Then there is a male. Male is already there. So that means it will become 2. 2 minus 0. And there is age band that is less than 20, that is 0, 1 minus 0. So total number of imbalance is 4. So we assign this third patient is into the control group. So same thing sequence we will do as continue till we get the desired sample size for this. I am again telling this method is a complicated method, so you can use a statistical software. First assign the patient randomly and then you put the characteristics of that patient into the model or software. He will assign, the software will tell you it will go to the control group or in the case group. So before going to the sample size, I will take a online calculator or sealed envelope to explain the how do you calculate the uh, randomization. You can see the screen for this one. You can see the screen of randomization. Can you write in chat box? Okay. So this is the sealed envelope, how to do the randomization using the block randomization and stratify randomization. For example, I have a two groups, group A and group B. This is the seed. Seed means you have a randomization generator number. So whenever you want to repeat that, you must know about the seed number. So whatever the it is written, you have to retain for the future repetition for this one. So we have a two group A and group B. So if this is the block size, because we have a two group, so you can put the block size of multiple of two. So I put first fix 4 block as a block size. Now length of this one, how much length is there? If you have a group A is 50 subject per group, so your length is 200. Sorry, 100. But 50 multiplied by 50. No, stratify, I am not putting here stratify. You enter the clear the list. So you will find that their list will be come for appear for this one. 100 block size is 4 and seed number is this one. You can download into the Excel by using this download CSV. So here is a block size number. Block size is this one, 1 2 3 4 patient assigned, and this is the group number is there. So here is for the fixed block size. Now what you can assign for the various variable block size of 6 and 8. Suppose 6 and 8 I am using and length is 600. Then I go for the creating this one. This is not exactly 100, but it is more than 100. So you can exclude the 4 cases from last of the this one. Last 4 cases you exclude to get the 100. So here the block size, first block size is 8, then group they are 4 in one group and 4 in another group. Second is also a 8, 4 in one group, second is another. Then The third is 4 size. Block size is 4. So here we have a various block size for this one. So this is, you can find out from the that we can use the various block size, or this you can download for the CSV. Now we come to that one, how to do stratify. If you want to stratify that, then you can write what you can write. Suppose I want to stratify according to the age. So I write less than 30 or more than. If you have a two group, less than 30 or more than 30. So this, and block size is 468 and length is 100. Stratify according to the less than 30 or more than 30. You create the list. It will give the 50 less than 30 or 50 more than more than uh, more than 30. So here the problem is in the stratified sampling. Whenever you give this actual list will appear to be more. So that you have to take care about that. If you are giving the length is 100, if you can reduce to the 95 or 94, then you can see whether we can get the near about that. Then 98 is there, or 96 we can create the 99. But problem is here is that you cannot get the exactly this one. So what is the solution for this one? You uh, what is solution for that one? Okay, because here the 112, that is a 66 and 66. So last six for the less than 30, or last six for the more than 30, you remove from that. So you get the uh, sample size of 100. So this is the method for finding out the randomization for block size or stratify. Or if you want to add some more factor here, I will add this one. You can add this with gender. You can write gender here, male, male, comma, female, and then create. So it will create less than 30 male, less than 30 female, and more than 30 male, more than 30 female, and like this. So like this, you can find out from the randomization. Randomizing. So this is the method for finding out the randomization. For the clinical trial, using the block randomization, using stratified randomization, minimize randomization method is not available in this sealed envelope. There you can use a good statistical software for this one, either Stata or SAS, for finding out the minimization method. So this is all about the sampling and randomization. Now we come to the sample size. So if you have any question regarding this randomization method, you can write in the chat box. We will discuss at the end of this session. Now we come to the sample size. In sample size, what is the important? First, we will discuss about the sample size. What is the importance of the sample size? Why we calculate the sample size? Is there a need for the calculation of the sample size? So first is that ethical issue. Whenever you uh, write a protocol or project, that after the scientific committee, it will go to the ethical committee. And ethical committee is check whether the sample size, scientifically sample size calculation is there or not there. And whatever the patient you are taking the patient correctly, uh, educate if you are taking the small sample. So whether your power is educate, if you are taking the large sample, to why you are large sample. So in that case, there is unnecessary, you are not giving to the some toxicity to the patient. So that is the ethical issue for this calculating the scientific calculating the sample size. Second is the cost. When you calculate the sample size, so you can determine the what will be the cost. If you involve the some cost is there, some drug cost is there, some test cost is there. So you can estimate the cost based on the sample size. So this is the variable cost. You can fix cost for maybe remain same, but the for sample size variable cost you can calculate for this one. And third is the time for this one. If you can have a sample in your hand, and your design is prospective design, retrospective there is no problem, but prospective design, you have to estimate what is the time requirement. I will take for completion of the sample size. So sample size determination help in finding out the what is your time calculation is there. Third is the fourth is the feasibility study. Now the feasibility study is when you calculate the sample size, then you find out whether you are able to do the study or not. If you calculate, suppose you have calculated the sample size too high for that one, and that study is not able, you are not able to do that one because of the subjects are now not available, logistic conditions are not appropriate for that one. So in that case, you can change the some your output primary outcome, or you can do the some multicentric, add the some other uh, hospital or other institution for this one. So in that case, it will help in finding out the feasibility whether you can do the study in your hospital, or you need the multicentric trial, or you need the some other things for that one. So that one is the feasibility of the study. Lastly, is the reliability of the study. If you calculate the sample size for the educate scientific manner, so in that case, you can rely study is reliable, reproducible, and also that one, or you can generalize for this. So that is known as a reliability for this. So these are the some important uses of sample size determination in the empirical research. Yeah, this is a not exhaustive list, but there may be or other reasons also. This is, but these are the some main reasons for main important things for the sample size determination. Now, in sample size, we have a two methods for that one. Writing this. Hello, Dr. Dharmender, are you listening? Hello. Uh, In sample size, we have a estimation and hypothesis testing. So first is the estimation. In estimation, what we do, we are estimating a population parameter. Here we are not comparing with the some other method. So we use the confidence interval method for that one. Estimation means you are estimating something, not comparing to the other thing. In hypothesis, you know, now it is visible. So sorry, I forget to the this again the share for this slide. Now I shifted to the this sealed envelope. Uh, Now in this, can I repeat that one again? The important shall I repeat the sample size slide again? That one's importance of the sample size determination in empirical research. There are mostly five important things are for the sample size. First is the ethical issue is there. क्योंकि because every study you plan for that protocol and the study plan that goes to the ethical issue. So ethical department or ethical committee will check whether the sample size is adequate or not, where you have taken the small sample size, then there is a wastage of the resources, or if you have taken the large sample size, so in that case there is an unnecessary toxicity to the other person. uh, so then that is called ethical issue. Now, second is the cost issue. When you calculate the sample size, so you can estimate the sample cost that is involved in the study for that according to your sample size. Third is the time. When if you have a sample size in your hand, so you can estimate the what is the time requirement to recruit the subjects. That is generally we happen in the prospective studies where we have to collect the some subjects from in the future. Fourth is a feasibility study. Feasibility study is if you calculate the sample size and you find that this sample size is not adequate for your study or you cannot achieve that sample size. In that case, what happen? You either you change your primary outcome or you can go for the some other multi-centric trials for this one. So that feasibility is of the study you can find out from the calculating the sample size. Lastly is the reliability of the study. If you calculate the sample size based on the scientific method, so that uh, study can be reproducible or it can be also generalized to the other study. So you can generalize it results for that. So that is called reliability of the study. Now the sample size. In sample size, we estimate is a two method for two areas for this. First is the estimation, and second is the hypothesis testing. In estimation, we are just estimate the parameter. We are not comparing the parameter to the some other population or some other values. In this, we are just estimate for this one. This method generally we applied in the survey to find out the what is the prevalence of the study or in this descriptive studies. Second is the hypothesis testing. In hypothesis testing, what we do in hypothesis testing, we compare one population parameter to the other population parameter to find out whether there is significantly different or not. So this graph I am showing that one. This graph is a sample size. This is the x-axis is a sample size and y-axis is the reliability. If you have a small sample, in a small sample you can easy to do and reliability is less. You cannot generalize or you cannot be reproducible for the small sample size. If you have a large sample size, in that case it is hard to execute, but your reliability is high for that. It may be the result may be reproducible. So we have to find out a sample size in an optimal way in between that. If we can achieve your sample size, also we have a good reliability for this. So in that case, their sample size formulas are we can apply to find out the sample size that is a uh, optimal sample size also and they are reliable also. So we will discuss about the this one sample size for estimation and hypothesis example. Now I will discuss about the some example practical example for estimation. To suppose we want to estimate the proportion of delirium in a palliative care patient. Our objective of the study is to find the estimation of the palliative care patient. Now the target population here is a palliative care patient. Those who are in palliative care, what is the proportion of delirium? So here we are not comparing anything. So here estimation. Now it will convert to the hypothesis testing. If we want to compare the proportion of delirium in cancer and non-cancer palliative care patient. So non-cancer palliative care, whether the delirium is less as compared to cancer patient. So here we are comparing the two proportion of delirium, that is called hypothesis testing. And first is estimation. Second example I am taking to estimate the proportion of neuropathic pain among the cancer patient using the LAN pain scale. This is the pain scale where we are using the neuro deciding whether the person has a neuropathic pain is there or not. So in cancer patient, we are estimating the what is the proportion of neuropathic pain. On the other hand, if converted into the hypothesis, if we are comparing the neuropathic pain in the cancer and the diabetic patient. So you can now understand the what is the meaning of estimation and hypothesis testing. Hypothesis testing is used when we compare one value to the another value or one value to the control value at historical value. But in estimation, we are not comparing the we are estimating with the specified precision level for that one. So that you should be cleared for the estimation and hypothesis. So first we will discuss the formula about the estimation, and then we will discuss about the hypothesis testing. So this is the some prerequisite requisite for the determining the sample size for estimation of a parameter. So first thing you have to do, what you have to do, choose the outcome of interest and the what is your target population. So you have to choose what is your outcome of what you want to. Suppose you want to proportion of delirium. So here outcome is a proportion of delirium. And what is your target population? Target population is palliative care cancer patient or palliative care non-cancer patient, whatever you want decided for this one, whether you are taking cancer patient or non-cancer patient. So this is your target population where your estimate should be generalized for that one. Second thing is that variability such as a standard deviation in case of continuous and proportion for qualitative can be estimated from the previous study, uh, pilot study, or expert opinion. The second thing is called variability. Variability is that how much is the standard deviation in case of continuous variable, and in proportion qualitative you take the proportion and find out the what is the variance for this. So this can be obtained from the previous study, or you can find out from the pilot study, or you can take the some expert opinion on that. How we can, if you don't have any study, previous study, so you can take the expert opinion, or if you are able to do the pilot study, in that case you can do the pilot study to find out the variability for this. Third thing is that what is the minimum degree of precision required for the or margin of error. Suppose you are estimating the proportion of delirium. So you estimate that the delirium proportion in cancer patient is 50%. But it is when you do the study, it may not be 50%, it may be 45%. Another study may you do 55%. So in that case, you decide what is the margin of error you allowed for this estimation. So this is a called precision level. How precise your estimation is this? If your margin error is high, in that case, your precision is less for that one. So you have a wide confidence interval. Your estimate is not reliable for this. So that margin of error or precision you have to select. Fourth thing is that confidence level in the estimation is usually 90%. You have to select what is your confidence level of estimation. That estimation we use 95%, you can increase to the 99% also. Now the sample size, this is the formula for sample size for the estimation, general formula for this one. Sample size variability, either variability in the proportion or for proportion or for standard deviation, multiply by Z confidence level. This is the confidence level. If you are taking the confidence level 95%, so in that case, you get the 1.96. If you have a confidence level 99%, in that case, the Z value is 2.58. Or you have 90%, in that case, you have a value of 1.645. So depending on the what is the confidence level, this Z value will change for this, and divided by margin of error. But you have precision you have selected, that is called margin of error square that. So this sample size you can estimate by substituting these three values for this. Now there are some adjustments are there if you have a subgroup analysis of that. For example, you are finding out the delirium population in palliative care, then you divide into the two groups, that is called young and old. So what is that? There are two subgroup. In that subgroup, delirium population may be different for this one. So in that case, you calculate the sample size for young or as well as old also for the this subgroup, and then do the your study for this one if you are doing for subgroup. Estimation of non-response. Nowadays what we have, what sample size, what subject you are including in your study, you have to take consent for that one. But sometime patient did not give the consent, so you have to estimate what is the non-response for this one. Those who are not giving the consent, for you have to add the attrition, that is non-response or attrition you can do for that one. Seventh is that the multiple outcome of interest. If you have a multiple outcome of interest, that means I want to estimate the proportion of delirium also. I want the proportion of hypertension also. I want the proportion of the diabetic also. So there are so many multiple outcomes are there. So in that case, you have to adjust for the multiple outcome. That adjustment is for the alpha level, you have to adjust for the multiple outcome. Or another thing is that you have to calculate for sample size for each outcome separately, and then whatever the maximum sample size is there, if you take that sample size. So, I am taking that one practical example for that. A researcher wished to estimate the proportion of delirium in a palliative care cancer patient in a hospital. A previous study reported that the proportion of delirium in palliative care cancer patient is 40%. How much sample size would be needed if the margin of error is 8% and the 90% confidence level? Now, before going to the practical, that I want to explain what is the absolute margin or what is the relative margin for this. There are in proportion we have a absolute margin or we have a relative margin. In absolute margin is that the margin of error is 8%. In that case, our confidence level or anticipated proportion is between 32% to 40%. That means around we are expecting around 40%. So minus 0.8, 32% plus 0.8%, that is 48%. So that is called absolute percentage. Then we come to the relative. Relative percentage precision is that relative error is k percentage of anticipated proportion. In that case, what happened? For example, if we say 20% relative margin of error of anticipated proportion of 40%. So that means we are expecting our margin of error 20% of 40%. In that case, you calculate 0.20 multiply by 0.40, that is 0.088%. Or same anticipated proportion could be between 32 to 48. Here the what is that? Same, it is absolute to relative precision. But what is that? In that case, if you take the 30% relative precision, in that case, our the precision level is 12%, or 10% you take, then it is a 4% for the relate. So you have to take, because I am I am telling, while calculating online calculator, you have to enter whether the absolute precision or relative precision. If you put the relative precision in case of absolute precision, so your result will be wrong for that one. So sometimes you get the high, sometimes you low, that is depending on this one. So you have to take distinguish between the absolute and relative precision. I am now we take the one another example for this one. For this is the practical example for finding out the proportion estimation of the proportion. A researcher wished to estimate a prevalence of hypertension in age group greater than 50 in the Delhi urban population. So our objective is to find out the prevalence of age greater than 50 year in a Delhi urban population. Our target population is a age greater than 50 year residing in Delhi urban population. Previous study shows that the prevalence is around 40%, considering the absolute precision 8%, 20% relative on either the side. Either the side means plus side also and minus side also. Now, with 95% confidence level, how much sample size will be needed? So our proportion here is 40%. This is the formula for this. N is a sample size. Z square 1 minus alpha multiply by, this is our variance for the proportion, pi multiply by 1 minus pi divided by L square, that is margin of error. So for 95% value of Z is equal to 1.96 square multiply by 0.4 multiply 1 minus 0.4 divided by 0.08 square, that gives the for 144. And similarly, if you are giving the relative margin, so this formula is there, you can get the same 44 subjects are. So minimum 44 subjects are required to be 90% confident that estimated population prevalence within the 16%, that is 32% to 48%. So this is the example for finding out the estimation of a prevalence using the anticipating of the proportion. Now we come to the Same thing if we want to estimate a sample size for the mean. Suppose I want to estimate a population mean for that one. The example is this: a survey is planned to estimate the average level of fasting glucose in a healthy female 40 to 60 years. Now I want to at want that average level of fasting glucose in healthy females. So our target population is what? 40 to 60%, and my primary outcome is average level of fasting glucose level. It is desired that estimating should be within 1.2. Now whatever I estimate, that is should be lie between the 1.2. This is the our margin of error. This with population mean with a probability of 0.95. A previous study revealed that an estimate of SD is 6.3. How big a sample size is required if the simple random sampling is to be followed? So our sample size formula for this is equal to 1.96. What is our standard deviation is 6.3 square. What margin of error is 1.2 square. That gives the 1.06 subjects. Now, I will try to explain if what happen if I increase the confidence level from 95 to 95, 99%. My sample size will increase because this is the numerator, this is the denominator. If we increase the numerator value, our sample size will increase. If we increase the denominator value, our sample size will decrease if other two remain same for that. So if the confidence level 1 alpha is raised to 99%, so our Z value is 2.58. That is our sample size will get n is equal to 1.84. Similarly, if the subject to subject, if I reduce the standard deviation from 6.3 to 2.4, what my sample size will reduce to the 16. So you can find out if numerator value I am decreasing, my sample size is decreasing for that. There are some practical issue. This formula now we will go for this practical examples also, practical using the online calculator. But before going to that, we I will tell the what is the practical issue in determining the sample size for estimating a parameter for this. So these are the important things are what is the precision for the prevalence study. Question is rather what precision is appropriate for that. Whether generally we expect that there is a 5% margin of error either side is generally considered appropriate if you have a true prevalence between the 20% and 80%. But for the small scale studies such as PGCC, you can increase the margin of error to the 10% if the number of available cases is small for that. So this is the relaxation for the PG thesis. They are recommended for that, but generally you take the 5% margin of error. This is if I take the 5% margin of error, our interval width of 95 confidence interval as 10 for that is the 30% to 40% for 20%, and the 60 to 7% if the true prevalence is 35% and 65. If my true prevalence is 35, then 5 I subtract here, 5 I add the 30 to 40%. Here 65 is there, then 5 minus 60 to 70% for this one. So if what happen is that if the prevalence is small, if the prevalence is a small less than 20 or more than 80, then margin of error 5% does not seem adequate. In that case, you have to take less margin of error. For example, I say that if the prevalence is 2% or proportion of a success percentage of a vaccine is 96%. So what happen is that if you take the margin of error 5%, so our the confidence interval is what? It will cross the limit 0 or 100%. That is 5. If you take 5% to 2 minus 5, that is minus 3. So there will go to the, that is less than 0. Your online calculator will calculate the sample size, but you have to take care. Our confidence level is going to be negative. It cannot be going to be negative. It should be 0 to 100% for this one. Only a lower margin of error is admissible. So in that case, 2% we take the lower margin of error. So you have to take care about that, whether what is the precision level probability, what is the prevalence or what is proportion you are taking for your study, and what is margin of error you can take that. Now another adjustment is that uh, these formulas are based on the simple random sampling. But if you are doing the some cluster sampling, or if you are doing some other sampling method, I am telling the sampling method, not randomization. Sampling method, then you have to adjust your sample size according to the design effect. What is the design effect? Design effect is that variance in other design effect is variance in other design divided by variance in simple random sampling. So we find out the what is the design effect. In some cases, most of the cases we found the design effect is greater than 1, but in some cases we can also find the design effect is less than 1. uh, uh, zero point 0.8, zero point 0.9 or less than 1. So in that case, you have to take care what is your design effect for this one. In cluster sampling, what the design effect is generally greater than 1. So how you adjustment that you adjust the sample size is that, and whatever you are calculating the sample size for simple random sampling, multiply by design effect. So you suppose your sample size is come 150, then or design effect you have a 1.5. So then you can 120 multiply by 1.5, that is equal to 225. So in that case you have to take 225 if you are using cluster sampling instead of random sampling for this one. So in the cluster sampling method, this is the formula for that one: n plus 1, n minus 1 intra-cluster correlation. That is difficult to find out, intra-cluster correlation. So generally it is recommended that you can take for the design effect for the cluster sampling 1.5 or 2. Between 1.5 to 2, you can take a design effect for this one. For the cluster sampling, I am thinking. For stratified sampling, it may be less than 1. So you have to find out first what is the your design effect for this. Now, this is up to the estimation of your sample size estimation method. Now, I will go for online calculator to find out how you find out the estimating a prevalence. What are the how you can calculate this one. You can see this calculator sign. You write in chat box, Dr. Dharmender. You are
Yes, yes, sir. It is visible.
uh, so this is the statulator menu for the finding out the estimating of the single proportion. So you type Google in Google as a statulator. It will appear as statulator.com, or you can directly download from this one. So when this is the sample size screen is there, estimation of the single proportion or estimation of mean. I am explaining this estimation of single proportion and estimation of mean. First click on the single proportion. When you click on the sample single proportion, you find that this is the level of confidence. Level of confidence, they are already fitting by default 95%. You can change by moving this as in 99% or other value. So I am keeping here as a 95%. This is your expected proportion. What are your expected proportion from that? So in that, our example is 50%, 40%. So I am taking here as a 40% as my expected proportion. Now, this is the precision or margin of error. Now, if you see that here, it is asking for the absolute and the relative precision. So if here the absolute, you can put here as a 8. And then you click on the calculator. I am putting the absolute 8% here, 0.8. 0.08. So in that case, you can put on the calculator, your sample size will be coming in the 1.145. Now, before this going to margin, I also want to show that this is the adjustment is there. There are some adjustment. When you click the adjustment of that, adjustment means there are some adjustment if you have a finite population. This sample size is assuming that your sample size population is infinite. But if you have a finite population, in that case, you can put here your sample size, finite population size. Like I am taking that example as a school is there 2000. So in that case, I put here the 2000. My population is 2000. Then I click on update, my sample size will reduce for that. So this is applicable for the finite population. If you uncheck that one, it will the infinite population. So first is for the finite population if you have a finite population. Other thing is that adjusting for the clustering format. Like I told you that the clustering adjustment is there. So clustering adjustment is you have a design effect or you have a intra-class correlation. We have a design effect. You click on the design effect or design effect, you put the 1.5 here and update. Then your sample size will go for the 217. So here there is a adjustment for the clustering also. I uncheck this one. Now third adjustment is the adjustment of response rate. Here it is a not response rate. You must care about the what is your response rate is there. So my response, if the my non-response rate is 10%, then I put here the 90%. That is the anticipated response rate for that one. I will click that my sample size will go to the for 145 to 161. So this is the online calculator. You can find out from the online calculator for estimation. Now, if I put here that relative things, you have to see that if I put the relative and I have not changed this one, my percentage I have not changed, the sample size will come to be 1001. So that thing you have to take care about that. Because whether you are entering the relative or whether you are entering absolute. Now, if I put here the 20%, 0.02, my sample size will come to the 160 same because I have taken that one adjustment. So I update, my sample size will come to be 145. Same thing is that if you have a no adjustment. Okay. So this is for the finding out the proportion. Now we come to the how we can find out for the estimation of mean. If you have want to estimate for the mean, so same thing is there. Level of confidence is 95%. What is your standard deviation? You have to take in our standard deviation. I have this 6.3. I have taken the for this our example 6.3. And what is the precision of error? Is my precision of error is 1.2. So I will calculate this one. My sample size is 109 for this one. So for estimating this one with the standard deviation of 6.3, 1.2, my sample size is 109. Now we come to the adjustment. Here also there are some adjustment are there. First adjustment are there is a finite population. That is similar to the proportion. Another adjustment is the clustering proportion. That is also I have already explained in the proportion. Here is that adjustment for the t distribution that is already checked. If I uncheck, my sample size will decrease to the 106. Generally, whatever the formula we are using here, I have used in the slide. I use the normal distribution for that one. But if you use the t distribution, in that case, the sample size will slightly increase to this one. So that depends on that what are you are using the normal distribution or you are using the t distribution. You are uncheck that one. In that case, you find that this is the normal distribution, or if check the distribution, in that case you find out that there is a t distribution in there. So while calculating this, you have to take care about the adjustments also. So this is all about that estimation for the single mean and the single proportion for this one. Now I come to the hypothesis testing for this one. Dr. Dharmender, you can see the now slide. Can anybody write in chat box? Okay. So now we'll discuss about the what is the hypothesis testing for this. In hypothesis testing, I already explained to you that one. We are comparing the two things, one thing with the other things. So in that case, addition to that, we have discussed, we have a information of the these things: type 1 error, type 2 error, variability of the variable, magnitude of effect, and the direction. These five things you must be know about that. Actually, we have did the prior the sample size, but before that there is a hypothesis testing and type 1 and type 2 error. So I will just give the brief idea what is the type 1 error and type 2 error. Type 1 error is that probability of rejecting null hypothesis when it is true. So we have a two things: null hypothesis and alternative hypothesis. Null hypothesis, we assume that there is a no difference, and in alternative hypothesis, we assume what we want to prove that one. So you have to take care what you want to prove, that is a alternative hypothesis, or what you are uh, reverse of that is null hypothesis. That so type 1 error is what? Probability of rejecting null hypothesis when it is true. In that case, what is meaning? We type 1 error is probability of rejecting null hypothesis. We reject the null hypothesis and accept the alternative hypothesis, but when the null hypothesis is true. The probability of rejecting null hypothesis when it is true, we falsely accept the alternative hypothesis. Or in other words, I say that a new treatment is ineffective compared to conventional treatment. A new treatment is ineffective, but the researchers say it is effective. So in that case, we are proving that it is effective, but actually it is ineffective. Or in a common name, it is called false positive level of significance, commonly fixed as a 5% level or 1% level. That is generally we fix on the 5% level for this. There are another type is type 2 error. Type 2 error is probability of rejecting an alternative hypothesis when it is true. We reject the alternative hypothesis when it is true. Alternative hypothesis is true, but we reject our alternative hypothesis. In other simple term, we say that a treatment is effective. A treatment is effective compared to conventional treatment, but researchers say it is ineffective. But researcher conclude that it is ineffective, but actually it is effective. So that is called false negative type 2 error, or usually we fix the 20% or, or 10%. Now, why we fix 5% here and 20% give the large margin for this? Reason behind is that if a treatment is ineffective but researchers say effective, in that case you are giving the threat to the patient, because you are giving the treatment and treatment is ineffective. So in that case, this is the a serious error for this one. But on the other hand, if it is ineffective or you are giving that, in that case, there is a no harm for that one. So we can relax to the 20% for this one. So you have to take care about that, how we fix the type 1 error and type 2 error. Another thing is the variability of a variable. That is called standard deviation. Now, that is a standard deviation. Measure the heterogeneity of the variable of interest in the target population. Generally, we take this variability as a standard deviation, standard error in the case of quantitative, and the proportion in case of qualitative data. So that is called variability. This is an important thing for calculating the sample size, because type 1, type 2 error is a fixed. Variability you have to find out from the previous study. And this is the most important factor for calculating the sample size. If this is wrong, in that case, your sample size is not adequate. If you take the large variability, your sample size is quite high. If you take the small sample size, small variability, your sample size will be small, but you are not get the desired result. So this variability is an important thing. You have to take care about that one, and you get this information from the reliable sources, or if you are taking the variability from the international studies, that may be different. Better you take the study that is most population, that is most relevant to your study. Or if you can do the pilot study, you can do the pilot study and find out what is the variability in that one. So that is the important thing I want to tell regarding the sample size, this one, for hypothesis. Another is the magnitude of interest. That is another important thing, is that what is the clinical important difference. And generally I ask when a person come to me for the sample size calculation, I two things I generally ask: what is the variability you have taken from the previous study, and what is the clinically important difference. This clinically important difference, they are getting the confused, student get the confused, and sometimes the senior faculty or faculty get the confused for the what is the clinically important difference to say that one. If I say the 5% is important, or if I say 5 is important, some for the variable, I am just giving the example for that one. Or so that clinically important difference is that difference. In that case, you say that it is benefited to the patient for that one. For example, I say 80 diastolic blood pressure. In diastolic blood pressure, if it is reduced to the 5 unit, that may not be drug, may not be uh, say clinically important if it reduced to the 10 mg. So in that case, 10 unit. So you have to decide before what is the your clinically important difference. Sometimes there is a Cohen D effect sizes. There are some like G power and all. They giving the Cohen D effect sizes there. So that they have mentioned the point 2 is some small effect size, point 2 to point 0.5 is a medium, and greater than point 0.5 is a large. Uh, if you have a large effect size, your sample size is small. If you have a small effect size, then sample size is a large. So these two things you have to take care about that. Another thing is that direction of that. Direction means you are doing the comparative study, you are doing the superiority study, you are doing the non-inferiority study. So in that case, direction is a must. So there are two type of direction, one-sided and the two-sided. In comparative study, where we don't know about the any planning of the study, where whether we get the benefit or whether we don't get the benefit, in that case, we go for the two-sided study. But if you have a literature proven, in that case, you can take the one-sided study, suppose non-inferiority. If you say the non-inferiority trial, our new treatment cannot be more than the standard treatment. So in that case, you can take the one-sided or superiority trial. You can find that new treatment is always better than the standard treatment. In that case, you can go for the one-sided. So these are the five important component for the while in the formula also, in the online calculator also, you have to decide for this one. Now we come to the some for example and formula for this one. There are some important consideration also regarding the sample size that I already, I think, explained for that one. But I just repeat that the main factor is the standardization or in the continuous variable, and the proportion in the binary variable. Important factor is effect size and clinically important difference that I explained. Sample size formula is based on the Gaussian distribution. If and sampling scheme is a random sampling, that one. Or then adjustment will be needed if the sampling distribution is not Gaussian distribution. So in that case, if you are using the T distribution for that, so in that you can adjust for that accordingly. And the sampling scheme is not simple random. In that case, you have to adjust the design effect for that one. Recommended value of type 1, type 2 error is a 5% and 20%, but it can be changed according to the consequence of the array results. Sometime that is sometimes data is skewed. Another author reports the median and interquartile instead of the mean and standard deviation. It can be converted into the approximate mean and standard deviation by using the formula that one article is available. You just put in the Google for and write the how to convert the mean and SD into median and interquartile to mean and SD. It will give, I forget the author name, but you can find out that one. Then sample size can be calculated assuming the normal assumption. And my suggestion is that you increase the 15% of the sample size to get the, so that you can get the educate result for that one. So in that case, if you are converting the median and interquartile to the mean and standardized sample size, should you enhance the sample size by the 15%. There is a need to check the assumption associated with the formula when the sample size is calculating by online website or formula, especially in the case of proportion. What are the assumption associated? You have to check. Now, that is important. Sample size is not necessary for every study, but justification is needed. For example, in MD thesis usually has a time and resource constraint. The sample size would be small regardless of the what the formula say. Our objective for the MD thesis is to know the student how to conduct the study, what are the components in conducting the study. So in that case, this is the learning process is MD thesis, and it may you can relax the sample size based on the time resources constraint. Now we come to the sample size formula for comparing the two means independent group. These are the some formula are this for the two groups. This is the first is the standard deviation of the first group. Second is the standard deviation of second group. Multiply by this Z1 minus alpha by 2, that is the level of significance, plus Z1 minus beta, that is power. These values are fixed at 1 point based on the 5%, 1.96, and 80% or 20% type 2 error or 80% power 0.842. The variable is standard deviation or clinical important difference. So two things are important for this. This formula is based on when the standard deviation in the two populations are equal. So you have to take care about this formula. If you have taking the population that have a different standard deviation, then you use this formula. Or second formula is that if you have a variance are equal variance, in that case, this variance are equal, then you this formula reduce to this one. So in that, this is the 2 multiplied by standard deviation square multiplied by Z1 minus alpha Z beta divided by the clinically important difference. So these are the formula for comparing the two independent groups. This is a one practical example I am taking. The suppose the difference of at least 1 gram of hemoglobin is considering clinically important between the patient receiving the chemotherapy and radiotherapy. We are comparing the hemoglobin level in the chemotherapy and the radiotherapy plus chemotherapy, whether their hemoglobin is at decreases by the 1 unit or not. The previous study suggested that the SD of HB in the CT group is 2 gram per deciliter, and in the CT per RT group is 2 gram per deciliter. That means standard deviation in the both the groups are same. The researcher wished to detect 1 gram per deciliter with 80% power. What the sample size would be educate if the level of significance 5%, equal allocation in the both the groups. Now this formula are applicable for the equal allocation 1-to-1 ratio. That means equal in one group is sample size of one group is equal to another group. I am not giving the example for the unequal. On when I go for the practical example, then I will explain for the unequal how to go for that one. So our null hypothesis that there is no difference in the hemoglobin level in the CT and RT groups, and alternative hypothesis is mean difference is at least 1 gram per deciliter. So we substitute here 2 multiplied by 2, 4. Our standard deviation is 2, that is 2 square is 4, multiply 1.96 or 0.82 divided by 1, that is give the 63. So our sample size per group. Here the sample size is per group. You have to note that sample size is per group. So total sample size you require is equal to 126 for that one. But if your clinical important difference increase to 1.5, here also the numerator and denominator, if you increase the value of numerator, the sample size will increase. If you increase the value of denominator, your sample size will decrease. So you have to, this generally question comes in the PG level or entrance exam. If you are increase the clinically important difference, what is the effect on the sample size? Or if you increase the power, what is the effect of the sample size? So, or if you increase the standard variance or standard deviation, what is the impact of the on the sample size? So this type of example in objective you can find out in the PG level. So you have to take care about that. If the numerator value is increasing, then sample size will increase. If your denominator value is increasing, sample size will decrease for this one. So you have, this is the, now we come to the sample size proportion for the comparing the, uh, comparing the two proportion. That is the two mean and now we are, this is the formula for comparing the two proportion. Now null hypothesis is that there is a no difference in the proportion law, and alternative hypothesis that there is a difference in the proportion. That difference is equal to that is clinical important difference delta. So this is a sample size formula assuming the two-sided and equal allocation. Unequal allocation, there is a complicated formula, so I am not writing here. This is the for the equal allocation where the n is a per group z1 minus alpha 2 pi bar. This pi bar is what? Pi bar is equal to proportion in one group, anticipated proportion in one group plus anticipated proportion in two group, that is divided by 2. This is the average of two anticipated proportion plus z1 minus beta proportion in one population, 1 minus proportion in one first population plus proportion in second population, 1 minus proportion in second population, and the square divided by the clinically important difference in the proportion. So this is the formula for calculating the sample size when you compare the two proportion for this one. Generally, we use in the case control studies or cohort study proportion where we have a two groups for that one. Now, this is the one practical example I am taking. That one, the investigator plan a study, a case control study with a 1:1 ratio to evaluate the thyroid status in a diabetic. The diabetic is our case group and non-diabetic is our control group. The thyroid status is divided into only normal and abnormal categories. You have to take care. We are dividing the normal and abnormal category, but under a stringent criteria. The objective is to assess whether there is any association between the thyroid status and the diabetic. Anticipated proportion of the abnormal thyroid in control is 15%. Now, in a abnormal thyroid in control group is 15%. How many subject per group is needed with 80% level or 5% level to detect a difference of at least 10%? We expect that in the diabetic patient, the thyroid level is greater than 15%, and if it is greater than 25, if it is 25, then we say there is a significant difference between the diabetic and non-diabetic for abnormal thyroid. How much sample size we require for this one? So we calculate the average of the two population for 0.25 plus 0.15 divided by 2. This is 0.20, and substitute in this formula 1.96, 2 multiply 0.2 multiply 1 minus is 8 plus 0.82 842, and substitute 0.15 multiplied by 85 plus 0.25 multiplied by 0.75 divided by 0.10, and we get the sample size of 251. So 251 cases and 250 control will be needed to detect a difference of at least 10 percent in the proportion of thyroid cases in diabetic and without diabetic cases. So this is the formula for finding out for the two proportion of this one. Now, something happen is that if we are not giving the two proportion, we are giving the case control study, we are giving the odd ratios are available in the past. So how to do if odd ratio is available, how to calculate the sample size for the comparing two. So in that case, our null hypothesis in odd ratio is 1. 1 means that there is a no difference in the odds of the exposure in case and odd of exposure in control. With alternative hypothesis, odd ratio is not equal to 1. It may be less than 1 or it may be more than 1. So now what this is the formula, we can transfer the odd ratio into the proportion 1 and proportion 2. But for this, we know what is the proportion 2 value in a control group. So we have a information to, we need the two information. One is that what is the odd ratio, and second thing is that what is the proportion of exposure in control group. If two information we get from the previous study, we can find out the proportion of pi1 using this formula. That is odd ratio multiplied by proportion of 2, 1 plus proportion of 2 odd ratio minus 1. So when we get the this pi1 and pi2, we can use the formula that is we are using previously to find out what is the sample size for this one. So I will take the one example for that to explain this one. Investigator plan a case control study to see the association between malnutrition and cerebral palsy. The previous study reported that the odds of malnutrition in cerebral palsy children is 7.8 compared to control. That is previous study is showing that one. The expected proportion of malnutrition in control group is 21.6% and odd ratio of malnutrition in cerebral palsy is 3 as compared to control, which to have 80% chances for detecting whether the odd ratio is significantly different from 1 or not. In the previous study, they are giving the odd ratio is 7.8, but we are expecting that if it is more than 3, then we say that there is a difference of between the case and control. Here, instead of taking 7.8, we are taking 3. So you have to take care because this odd ratio, you have to decide what is the odd ratio for the important for you. Okay, because it is a high odd ratio. If you take this odd ratio, that sample size may be less. So you have to decide what odd ratio you are expecting. So generally, it is if it is you have a 2.5 or 3 or 4, so that is a sufficient for that one. So here we are assuming that the 3 is sufficient for them. So we calculate the sample size based on this one. Malnutrition among the cerebral palsy is equal to 0.53 that we calculate from this formula. 3 multiplied by 0.16. This is the cerebral palsy in the control group. 1 minus odd ratio, 1 minus this one proportion multiply by odd ratio minus 1. That is 3 minus 2. 1 get the p-value. P1 is equal to 0.53. So we can get, we find out the pi1 and pi2 value, and using this same formula, we can calculate the sample size for finding out the what is the sample size we need for finding the odd ratio 3, having the malnutrition proportion 21.6%. So this is the based on the odd ratio and the population of exposure in a control group. Similarly, if there is another issue is that sometimes we are doing the for the relative risk. So how we calculate the relative risk for that one? Same, this is the formula for the relative risk for calculating if you have we require for the relative risk value and the what is the proportion of disease in non-exposure population. What is the proportion of disease in non-exposed population group? Two things we are required. What is the relative risk? And this is the proportion of disease in non-exposure population group. We calculate from these pi1 and pi2 and then find out the sample size using the similar formula for that. So this is for the odd ratio, and if you have a relative risk and proportion, then you can use this formula to find out the pi one value. Pi 2 you have, you can substitute this in this, you can find the sample size for this one. Now I will explain the one example or also. The two competed therapy A and B to treat the breast cancer are to be evaluated in a clinical trial of the stage 1 and stage 2 patient. The patient are randomized into the two group and follow for recurrence of the disease after the 5 year of the treatment. So here we are finding out the two therapy we are giving, treatment A and treatment B, and patient are randomized into the two group. How many patients should be needed? Each group in a trial of within 90% confident of rejecting null hypothesis, relative risk 1 in favor of alternative hypothesis, relative risk not equal to 1 with 95% confidence level, a reduction in the mortality using treatment with a relative risk of 0.5 and expecting the recurrence after the 5 year of B treatment is 35. So we have a relative risk in the 0.5 in new treatment, one therapy group, and there is a treatment is 35%. So using this formula, we can find out what is the proportion of your recurrence in the one group, that is a 0.17. If you have a 35%, relative risk is a 0.5 multiplied by 0.35, that is a half of the what is the getting you are getting in the treatment B. So we have a value of pi 1 and we have a value of pi 2. We substitute this in the formula and we can get the sample size for the two groups for that. So for the relative risk having the uh, proportion on the non-exposed population. So these are the method for calculating this one. Now we come to the allowing the some adjustment. This is the common thing, common error the student do in calculation of the sample size. So I think I will explain that. There is a loss to follow up, lack of compliance, other losses. So these you have to adjust according to this in your sample size. But what we do, the student do is that suppose a sample size is 150. The researcher expected 50% loss to follow. Then what is the required sample size is 150 divided by 1 minus 0.5, that is 177. This is the correct method for this one. But generally what type sometimes student do is that 150 plus 150 multiplied by 0.15, so that come to 173. So there is a difference of 4. This is the wrong method for that one, for calculating. So you have to use this formula for calculating the sample, accommodating the loss to follow up. Generally I found in the articles or in the thesis sample size calculation, they use this method for calculating the sample size. So that is the wrong, some number you lost in that case. So you have to take care about that using this formula. Now, how to report that sample size? That is also a must. What things are reporting that? Generally, we found in the statistical method paragraph sample size description. So these are the following things you have to include in the sample size. Primary outcome of interest for which calculation have been provided. What you write the primary outcome. Justification of prior estimation used for the calculation. What is the reference for the, whether you are using your observation, whether you are using prior estimate for prior calculation, you are using pilot study. So that you can have to write from where you are using the standard deviation. And if you are using the estimation, in that case, you have to give the standard deviation, margin of error, and the confidence level in case of continuous variable, or proportion, margin of error, and confidence level in a case of proportion, or uh, for continuous variable, standard deviation, margin of error, or confidence level, or in case of proportion value, margin of error, or confidence level. So three things you have to give. If you are going for the hypothesis testing, then for the continuous variable, you have to give the standard deviation, clinically important difference you have to give, what is the power you have taking, level of significance. So these things are important. Apart from this, if you are doing for the iteration is there, for or if you are doing the subgroup is there, if you are doing the some multiple outcomes are there, if you are adjusting for the multiple comparison, a multiple time adjustment is there. So in that case, you have to adjust according to the level of significance that I am not discussing, but you can find if you have that one multiple outcome and multiple testing for that. Multiple outcome is different, multiple testing is different. Multiple outcome means you have it two or three primary outcome. So in that case, multiple outcome. Multiple testing means you have a follow-up study is there. So you are testing baseline to the time 1, time 2, time 3, time 4. You are 4 comparisons are there. So in that case, you have to adjust for this one, or you have a number. If you have a number of group 3, more than 2 group, or more than 2 group, 3 group, or 4 group, that is you have to either you go for the F test using online calculator, or if you are using t-test for calculating the uh, 3 groups, then you have to adjust the level of significance accordingly. That one. So software formula. So what are the software you are using? You just report that this software you have calculating. If you are using formula, better you give the formula for this one, not for the manuscript, but in the case of thesis, you write the formula of that. All things are essential information such that anyone can read the sample size section would able to recalculate. Whatever, if you want to recalculate the sample size for the giving information, so that is a more appropriate way of describing this one. So all this is the one template I am for the estimation. This is the template. This is from the previous study. Give the reference. Reported the proportion of disease ranges from 20 to 30, or maybe a single value. Expected 30% proportion of disease in present stating population at 5% margin of error on either the side. 95% confidence level. We require a sample size. Sample size you have to fit with continuity correction or with not, with a sample size with continuity correction. This is the different continuity correction. Uh, uh, a sample size is determined using the package. Write the name of this or formula. Write the formula for this one. If you are using the mean, the previous study reported the standard deviation of a primary variable unit expected a margin of error unit on the either the side with 95% confidence. We need a sample size. We need a sample of a dash of object in present study. So these are the template for the estimation. Similarly, their templates are available for the hypothesis testing. So you can write whatever you have calculating, you justify by the writing this one. So that is the must. Now I go for the statulator to calculate the how you calculate the sample size for hypothesis testing. Dr. Dharmender, you can see this screen.
Yes, yes, sir.
Now, this is for the comparing the two proportion. If you are two proportion, you click on the two proportion here, and here is the equality, non-inferiority, superiority, and equivalence. I am explaining here only the equality for this one. Non-inferiority and superiority and equivalence, I think it is difficult to cover in the 2 hours. So I will explain here the equality for this. If you have a equality, then you have to give the what is your expected proportion in one group and what is the expected proportion in the second group for this one. So if you take the reference here as a, I don't remember what is the value. If you take the 40% in one group and 20% in the another group, and then calculate the sample size, what is your sample size for the equality, you get the sample size for the 89. So for detecting a difference of 20% between the two proportion, we get a sample size of 89. So this is the calculation. After calculation, you can go for the options also. Option, you click on option, then it will ask for the what is there. If you want to change the power, you can change here the power for the 80 to 90%. Level of significance, you can change from the 5% alternative hypothesis, I said by default it is a 2%, two-sided, but you can change into the one-sided. You can click on the one-sided. And then here is a group size. If you put one, then it is a 1-to-1 ratio. So I am putting one here. So 89. If I put here the two, so that means I am taking the one control and two case, or two control or one case, vice versa. In that case, we need a 63, 63 subjects in test group. If I take one test group and 126 in a control group, total sample size is 189. So in that case, you have a 2:1:2 ratio. Or if you can change 0 to 0.5, in that case, reverse of that. 71 it is a change, 71, and the total sample size, what is the total sample size is 172. So here the value is change depending on the your what ratio you are giving for this one. I am keeping here one as now another adjustment. Now this is the option adjustment. Adjustment is like we have discussed here, the continuity correction is there. What is the meaning of the continuity correction? I have not explained. The continuity correction is what we are using the this is normal distribution, but we are using proportion for that. To make a normal distribution is a continuous distribution, and our proportion is you use binomial distribution. So in that case, to make a continuous binomial distribution, for making the continuous, in that case, we use the continuity correction for this one. So if you apply the continuity correction, your sample size will be high. If you not uncheck that one, your sample size will be 79. This will sample size you will give from the formula. But if you continuity correction, your sample size will large, but there is a different formula for adding the continuity correction for this one. That is a complex method for continuity correction for addition. So that's why I am not describing here for this one. But you can use the software if you want the continuity correction. Second thing is that adjustment of the clustering. Same thing I have explained already that the adjustment is there. Then about the response rate. Here you have to clear that this is the response rate. This is the non-response rate, not non-response rate. It is a response rate. So whatever the non-response rate, you should one minus that is if your attrition is 10%, yeah, non-response is 10%, so you have to put 90 here. So in that case, your sample size will be increased. That is divided automatically divided n by 1 minus L. So this is a method for calculating the sample size for proportion. Now here you see that the measure of association. If you click on the measure of association here, then first we have checked for the difference for this one. Difference is that whatever we have taken is 40% and 20% difference is 20% that one. So this is the difference in proportion. But now if you want have a relative risk, you can put the relative risk here, and this is the reference population for this one. If your relative risk is 2 and the expected reference population is 4, then you calculate it is coming the 22 for this one. That you take care about that one. What is your, if you're in decrease this one, your sample size will be increased, or if you increase the reference population, your sample size will decrease according to the relative risk. Again, if you have a odd ratio proportion, is that in odd ratio, then you can put what is your odd ratio. Suppose you give the 1.5 odd ratio, and then you here put the what is the control proportion value and calculate your sample size will be. So you can play with this calculator by giving the difference in proportion, by giving the relative risk, by giving the odd ratio. Now we come to the sample size calculation for the two independent mean. If you are comparing the mean, you click on the mean, then it will ask what is based on the expected mean, what is, and the another is expected difference between the mean. So there are two things are there. expected mean, if you have a expected mean is there, mean of one group is there, mean of second group is there, standard deviation. Here it assume the standard deviation equal in the both the group. This is not applicable when you have a different standard deviation. This calculator is not applicable. So this assume that there is standard deviation is similar to that. So here we have assumed that 25 in first group mean, second group is 35, and standard deviation is 15, and we calculate that our sample size is 36. That means to detect a difference of mean in 10 unit with a standard deviation of 15, we require a sample size of 36. So this is the calculate. Now we come to the option. What are the option are there? You click on the option, desired power if you want to change, if you level of significance, alternative hypothesis, and the group size. If you want have a group size, unequal group size, you can change in the unequal 1:2 or 1:3 or 1:4, whatever you want to change, you can change in the group. This is referring to test group. Then we come to the adjustment. What are the adjustment are there? So first adjustment is here the clustering adjustment. And at clustering adjustment, you put the design effect, because generally we don't know about the intra-class correlation. So design effect, we assume that 1.5 to 2 in that clustering. And the second thing is that the adjustment of t distribution here, because we are using the formula based on the normal distribution. If you uncheck that distribution, you will get the sample size of this one 36. There is a not much difference is that. But if you check this one, update that, there is a notch. But sometimes you find that there is a difference is there. So in t distribution and there is a normal distribution, there is a slightly difference of that one. In I proportion, in estimation, I show that there is a difference of the 3 is there, but here it is not coming uh, in the t or normal. Sometimes it happens that there is a not much difference. Or if I decrease the standard deviation, then this is 4 and adjustment is again 4 is coming. So there is a not much change in it there. If you take the distribution and or normal distribution. Second cheese is that there is an expected difference between the mean. If you have you don't have a mean, but you have a standard deviation. Standard deviation is 15, and you put that there is a difference in mean. What is the difference in mean? So you put that the difference in mean here. You not aware what is the mean and in one group and second group, but you know that we want that this clinical difference is our difference is 10 unit. If the difference between the two groups is 10 unit is there, then there is a clinically important difference. So you can put the difference between the two mean and then calculate the sample size 36. And same thing adjustment you can put here. So there is not much change for the adjustment for the t-test and the normal distribution. But if you adjust for the clustering, here for the design effect for the two, so it will go to the doubling that one 36 to 72. It multiply by the 2. Or if you go for the option for this one, change the unequal to equal, that you can, this is the 53 for the test group and the 106 for the double the reference group. So this is all about the calculator for comparing the estimation mean and the comparing the proportion. So there are, I'm not discussing about the non-inferiority trial. Dr. Dharmender, if your time is there, then I will discuss or no. Dr. Dharmender? Now all about this. I think today lecture is all about. So now we can open for the your questions. You can ask the Dr. Dharmender if you want to. ask any question, you can unmute and then ask for this one.
Hello.
Thank you, sir.
Hello.
Thank you, sir, for the laboratory session. Participants, you can ask your queries if you have any. You can unmute.
Hello, sir.
Yes,
Hello,
please.
sir. Am I audible?
Yes.
Sir, thank you so much for the wonderful lecture. So many doubts has been clarified. I still have like two questions.
Yes.
First question is, when we take 99% confident interval, power of the study also increased, reliability also increased. But I haven't seen so many papers or not a single paper with 99% confidence interval. Why? Like if prevalence is above 50%, it is not feasibility is not an issue. Second question is, if prevalence is less than 2%, like if you take relative pressure also, the value come near to 5,000 population, which is not feasible. Like how to proceed in that case. I read the article regarding this. They mentioned like if prevalence is less than 10%, we can take half of the prevalence as an absolute error. Whether that is true, like how to solve the sample size calculation issue in this case.
If you have, I told her, you can, in that case, you can take the relative precision for that one, or you have to take the either if you are
Sir, actually, sorry to
Yeah.
interrupt. My thesis protocol is regarding DMP usage. The prevalence of DMP is like 2%. If I take absolute pressure, like absolute pressure as 5%, then its sample size would be around 15K. If I take relative pressure, the two as 20%, sample size would be around 5K, which is not feasible.
Around what is?
Yes, sir.
You are taking the relative precision, what about
20% of the
like
2% of the
if
prevalence.
you are taking the 2%, then your confidence interval is a 0.8 to 1%, to 1.2%. So
Yeah.
sorry, 1.8 to 2.2%. If you have a 2% in that case.
Yes. In that case, also we get 5K samples.
In that case, you can increase the relative precision for 20% to 30% for that one, or to 35%. You have an option for increasing for that one.
Yes, sir, but the power of this study also decreased.
Like, you are first you tell me the what you are estimating that one, or you are hypothesis testing. There is a two things, different things there.
Estimating.
Estimating, then there is no power for that one. In
Like
estimation,
reliability won't get reduced if I increase the relative precision.
in that case, you can say reliability of that may be decreased, but either if you want, that is why we are calculating the sample size. Like if you are not able to do that one, so you can opt for the another option for that one. Another option is to check for the another outcome.
Prevalence.
Another not 50% prevalence for that one, but 2% you have there, but another outcome for that one. Not assessing this outcome, you go for the another outcome, or you revise the primary outcome for this one, or you take
So one more question.
One. Yes. Second thing.
So like reliability is increased in 99% confident interval. If prevalence is like above 50%, then feasibility won't be the issue. If I increase to confident interval to 99%, but I haven't seen any study with the 99% confidence interval.
Generally, if you find out the
Why?
study, why this is that if you increase the 90%, 99%, so that sample size is your increase. And generally 5% is acceptable to the all the manuscript or literature or statistician accept, or the some all scientists are accepting the 5%. So generally they don't go for the 99% for this one. So this is the one of the reason for you don't find that. Similarly for the power, generally we take 80% power. That one rare study we go for the 90% power for this. So that is a matter of that one key. If you want to you have a sample size, or you can go for the sample size for the 99% confidence interval. So I don't think you can go for that one. There is no nobody will object for that one if you go for that.
Thank you, sir. Thank you so much. I will mute myself.
Sir, can I ask a question? Hello.
Yes.
Sir, suppose I am comparing non-technique or old technique with a new technique, and for that I have one mean of old technique, and mean of new technique is not available. Then how to proceed for that? Because I don't have mean of other technique or ST of other techniques.
Generally,
I have only
generally what happen is in the sample size calculation, we usually have a one group mean is available with the standard deviation. Okay, second, if we available in second group, why we do the study for that one? So the question is that one. Or you want
So
to
we want
repeat?
to compare one study or existing study to a new one, or one technique is being
No, no,
compared with another technique.
just listen to me.
Yeah.
If you have a mean for the both the groups are available to you, so there is a less reliability of the research research you are conducting. So you
Okay.
conducting a research that the one group is there, another group is unknown to you.
Yeah.
So you assume that what will be the clinically important difference. So first you have to check whether
Okay.
you are going for the equality superiority trial, whether you are going for the inferiority trial, whether you are going for the equality trial. So generally we go for the equality trial. And what
Yeah.
is the clinically important difference to say one group that this new drug or new treatment is better than other treatment. So that is the main important thing for that one. If
Okay.
you have a suppose one treatment is relieving the pain for the 50% patient. Okay?
Yeah.
So if you are giving the new treatment, to how much pain you 50, to increase from 50% to 60% is better, 10% is sufficient for you, or if you say 65%, then I say better, or 55% it is better. So that depends on the situation. If you say the
Yeah.
mortality, you said 5% is better. But if you say pain relief, then you go for the relaxation 15%, we say good. So if you want to increase the life with a 1 year or 2 year, 6 months, even the 6 months are important for the patient.
Yeah.
So that depends on the situation to situation. So clinically important difference is must.
Okay.
You have to find out, not find out. If it is not there, then you have to find from your expert, or you
Right.
can think out that what may be the clinical important difference for this one. So we can take for that, or you can take the 5%, 10%, 50% different type of. Then you calculate sample size, whatever feasible to you, you can calculate. But that is a rough estimate idea is there. So better is you can ask your expert,
Yeah.
study expert, what will the clinical important. If you are giving the new treatment, what gain will be important for this one. It is not
Okay.
necessarily you will get the mean from the other group in the literature. It may be possible you get or you may not get. But if you have a one mean is there, that is sufficient.
Okay.
Good evening,
Okay.
sir.
Thank you, Anas.
Hmm.
I want to ask, like, in those kind of studies in which, like, previous studies are not available to compare, like, we don't have any previous samples or like prevalence or something like that. So, in those kind of trial, what will be the good sample size? Like, if we are not able to calculate, so what will be the sample size so that we can generalize the findings?
No, there is a not a arbitrary number is not sufficient for that one. But if you are doing the proportion, it's an estimation study. In this estimation study, if you are expecting that my proportion will lie between the 20% to 80%, in that case, you can take the 50%, because in 50% it gives the maximum sample size. So in estimation you can take, but if you are hypothesis testing you are taking, so you cannot take the
Yes, sir.
50%. In that case, one group is required for this one. Another group you can uh, expect from that 10% or 40%, but one group is necessary. Second thing, if we are not able to get this one, you can do the pilot study. Second thing, you can ask for the expert opinion for the subject person. What will be the your expected prevalence is there, or if there is retrospective study there, you can see from the hospital record from the last 1 month or 15 days, what is the prevalence of that, or what is the proportion of this one. So some information you can get from that one. Otherwise, there is a not difficult to calculate the sample size if you don't have anything for this one. Not a arbitrary number, not you take the 50% number or say 100 number, or you say that is a not recommended for this one.
Okay, sir. And my second question is like, if we talk about the inferiority, superiority, or like equivalence trials,
Yeah.
so can we do it directly, or it is necessary to do like on lab first, in lab first?
No, no, in phase three,
Trials.
in phase three, you can do that one. There is no need for the phase one and phase two. Phase directly, you can do the non-inferiority trial for the phase three also. But the treatment you are giving, what are the treatment already standard treatment is already acceptable. But whatever the new treatment you are giving, that is also be fully past phase one and phase two trial. In that case, you can do the phase three trial for the non-inferiority. If it is a new non, it is not clear by the phase one and phase two. That in case you cannot do that one, large one, non-inferiority
Okay.
trial.
Thank you so much.
Hello, sir. Good evening.
Good evening.
I want to know in which type of studies the calculation sample size is exempted.
Exempted. That is a good question. That is exempted. Uh, Exemption is I don't think exemption. If you are going for the arbitrary number, that exemption is that like animal study. In animal study, you can take the 5 or 7 sample. There is no need for calculating the sample size for this one. Or there are
Can I
yes.
interrupt you?
Yes.
Sir, like in Corona time, many authors said that you can take convenient sampling for your thesis purposes because of restrictions in Corona time. So, can we take convenient sampling also sometime when we are not able
Convenient
to?
sampling, or you are asking sample size, convenient sample size, or convenient sampling? You are asking?
Convenient sampling in case of
Convenient
to
sampling is
calculate the sample size.
convenient sample होगा. Convenient sampling is different. Convenient sampling is that you take the whatever the sample you are available, you take that. It's
Right,
convenient sampling. Convenient sample means whatever
right,
the sample you are available to you, that sample size you are taking.
right.
There is a difference between convenient sampling and there is a convenient sampling, non-parameter probability sampling that I have not discussed in that. But there is a difference in that. Convenient sample size is there because if you calculate the sample size and you don't have a COVID patient in that case, what option is it? You don't have a some thing for complete that study for this one. So in that, they are suggesting whatever that because there is a necessity for the development or patient, we don't know about the what is the consequence of the corona in which condition. So that's why whatever the sample size you take, you can take that one. In pandemic area, I think
Right.
they're asking the question in what in which case you can take the sample size arbitrary. In the I think in pandemic area conditions you can take that one.
Sir, for
If
these
you are doing
retrospective
the
studies,
sir,
if you're
just
looking
a
at
continuation of my question.
Huh?
So, if you are doing, sir, for the sample size, I had asked the question regarding the exemption. So, if you are doing a study for a short period, like 2 months or 3 months, whether you can take a smaller sample size without any calculation, just a arbitrary sample size.
Which one you are saying? Just repeat the question.
So, if you are doing a study for a very small time, that means around for two
Small
months or
time.
3 months,
Okay.
small period of time.
Uh,
So in that case, can we take a arbitrary sample size of a very small number of subjects?
no, in that case, what is the objective for this one? That I want. If your objective is just phase one trial, you testing the new trial drug. In that case, you can take that one. But in or if in oncology there is a short life that sites are there that have a short period. For example, lung cancer. Lung cancer has a very 6 months to 1 year survival. So in that case, you can calculate the sample size. But if you are taking the breast cancer for 3 months, there is no use for that.
Okay. Yes, sir. Thank you, sir.
so for these retrospective studies that you're looking at treatment outcomes over the period of 5 years,
Uh-huh.
uh, why do you need a sample size calculation? Because you're going to take all patients that have come to your institution